Hello everyone. In this video, we'll start solving questions from chapter 1 making measurements. We'll be solving question number 31 to question number 40. Let's look at question 31. A student measures the volume of a small irregular shaped stone. Which apparatus is must be used? So to measure the volume of a small irregular shaped stone, we can use a measuring cylinder and water. So we do not need ruler for this. So we can say option B, a measuring cylinder containing water only. Let's look at question 32. A measuring cylinder contains 10 cm cube of water. A piece of steel is lowered into the measuring cylinder until it is fully submerged. The volume reading increases to 12 cm cube. So initially we had 10 cm cube of water in our container. Right, let's say this was 10 cm cube. After submerging a piece of metal, the volume raised to 12 cm cube. Then what would be the volume of the piece of metal immersed? It will be 12 minus 10 to 2 cm cube. So 2 cm cube is the volume of the steel which is immersed. Now a second piece of steel is lowered into the measuring cylinder so that it is fully submerged. The volume reading increases to 15 cm cube. Now they are saying that we have one more piece of metal and we have submerged it. Now the volume now increased to 15 cm cube. So the volume of the first metal was 2 cm cube. Right. So V1, I'll call it as 2 cm cube. Now if I want to find what is the volume of the second piece of metal, we have to find what is the increase in volume. So initially the volume was 12 cm cube. Now it increased to 15 cm cube. So the change in volume is only 3 cm cube. So the volume of the first piece of steel is 2 cm cube and the volume of the second piece of steel is 3 cm cube. So the correct answer is option A. Let's look at question 33. A student uses a ruler to find the volume of water in a tank. She measures the length EF and FG. So EF is the length of the tank. Now FG is the breadth of the tank. Now what other length does she need to measure? Now the other length which she can measure can be either FK or FJ depending on what we want to find. So here if I want to find what is the volume of the entire container, then you could have used FJ. But in the question they are asking us what is the volume of water in the tank. The water in the tank is the shaded region. So the height would be the length FK or it can even be GH. So in the examination if you don't find FK or KF, so they might give you GH or HG. So here this will be the height of the water in the container. So the other thing which you need to measure is this height Fk. So the answer is option B. A student measures the diameter of a pencil. Which measuring instrument will give the most precise reading? To get the most precise reading, we will use a micrometer screw gauge. So it is option C. Question 35. A student measures the dimension of a cylindrical glass beaker. For which measurement should she use a micrometer screw gauge? Now, let's look at option A, circumference of the beaker. Circumference is too large, so we won't be able to, micrometer screw gauge might not be the best instrument to find the circumference. Even diameter can't be found. We will use a vernier caliper. So for circumference, we'll first find the diameter, divide that with 2, then use the formula 2 pi r to measure the circumference of the beaker. But here for diameter we would still use a vernier caliper, so we won't be able to use a micrometer screw gauge. The height of the height of the beaker, again we'll use a vernier caliper or a meter ruler, so we won't be able to use micrometer screw gauge. Thickness of the glass wall of the beaker, so this can be measured using a micrometer screw gauge. So the correct answer is option D. Let's look at question 36. Which is the best apparatus to use to measure the thickness of a coin? So to measure the thickness of a coin, we can use a micrometer screw gauge. Now, question 37. A digital stop clock measures time in minutes and seconds. The stop clock reads 00:50 when it is started, that is 0 minutes 50 seconds. It reads 02:10 when it is stopped. What is the shortest possible time that has elapsed between the starting and the stopping the stopwatch? Alright, so let's look at what is the initial reading. The initial reading is 0 minutes 50 seconds. So let's just call it as 50 seconds. Let's call it as T initial to be 50 seconds. Let's try to calculate what is the final time. So T final is 2 minutes and 10 seconds. So let's convert this 2 minute 10 seconds into seconds. So a minute contains 60 seconds. So 2 minutes implies it is 120 seconds plus 10 seconds. So the final time is 130 seconds. Now if I want to find what is the change in time, the time elapsed, so it will be T final minus T initial, that will be 130 minus 50, which is 80 seconds. Now in our options we don't have 80 seconds, the answers are given in terms of minute and seconds. So here we can convert 80 seconds to minute and second. It will be 1 minute and 20 seconds. So the correct answer is option A. Question 38. Diagram 1 shows a measuring cylinder containing water. A metal weight with a cork attached by a thread is held above the water. Diagram 2 shows the apparatus after the weight has been lowered into the water. Diagram 3 shows the apparatus after the weight and the cork have been submerged. What is the volume of the cork? Now, we use this method when we have objects that can't be completely submerged in water. For example, rubber. So, rubber is partially submerged in water. So, we can't use Archimedes' principle to find what is the change in volume. So, we have to completely submerge this object. So, we'll tie it with a small piece of metal, maybe a bolt, and just drop it in. So, first we have to find what is the change in volume when this piece of object is completely immersed. So initially it was reading 15 centimeter cube. After immersing the metal, it is reading 25 cm cube. So I'll write this down here. So initial reading is 15 cm cube. So the graduation is 5 cm cube. So here it is 5, 10, 15, 20, and it will be 25 out here. So this is 25 cm cube. Now let's read what is the final volume. So the final volume is here, which is 45 cm cube. To find what is the volume of this piece of cork, what we need to find is what is the change in volume when this object is completely immersed. So it went from 25 cm cube to 45 cm cube. Then the volume of the object will be equal to 45 minus 25, and that would be 20 cm cube. So the volume of the cork is 20 cm cube. The correct answer is option A. Question 39. The diagram shows a measuring cylinder containing liquid. What is the reading of for the volume of the liquid in the cylinder. So let's look at the graduation. Each graduation is 2 cm cube. That means if this is 10, this will be 12, 14, 16 and so on. So when I'm measuring this, I always have to measure the lower meniscus, and the lower meniscus is coinciding with the 16 centimeter cube mark. So here this is 16 cm cube. That means the volume of water in the cylinder is 16.0 cm cube. It is option C. Which quantity can be measured directly using a micrometer screw gauge? Area of a sheet of paper? No, we can't measure the area using micrometer screw gauge. Mass of a sheet of paper? No, we'll need a measuring pan. Thickness of a sheet of paper? Yes, certainly we can use micrometer screw gauge to find the thickness. Volume of a sheet of paper? Still no, because we can't find volume using micrometer screw gauge.